Hello, this is Charlene. We are going to find the domain and range of this equation. Our equation says that we have y equals x squared minus 4x minus 5. The first thing that I would want to notice and want to make sure that I understand is what kind of equation is this? This is a quadratic equation. The reason why we know it's a quadratic equation is because the highest power on the variable, or the x term, is a squared. That tells us it is a quadratic. It also has an invisible plus sign in front of it, which means it's a happy quadratic, which means when we graph it, it is going to look like this. It's going to look very happy. And we can draw some teeth in there if we want to remind us that how happy it is. But anyway, that's what it's going to look like. So if you can remember what that looks like and recognize that from the shape of the graph, it will go a long way toward you understanding how to find the domain and range of this kind of equation. So let's go ahead and take this off. You actually can go ahead and go over to Desmos. You can put in your function here. Here I've put in y equals x squared minus 4x minus 5. And you can see again, it confirms that it is a happy parabola. Okay, but let's go back over here. And I've already pulled up a copy of this. Oops, where'd it go? A copy of this graph. So when we pull up this graph, we need to consider the domain first. The domain includes the x values. So just remember, domain means x values. X values have to do with the x-axis. And the x-axis, how does it move? Does it move from left to right or up and down? Well, the x-axis is from left to right. So we're going to consider this graph. How does it move from left to right? So where does it start? Where does it start down here? And where does it go to? Well, this graph theoretically will continue. There would be like a little arrow right there. And that arrow means that it continues. It continues forever and ever and ever. Well, then where is it starting from on that left side? It's starting from negative infinity. Okay, and then on this other side of the parabola there, it will be a little arrow, and it means that it's continuing this direction. So forever and ever, this direction would be positive infinity. So we need to understand what is negative infinity to positive infinity. If you wanted to write this in interval notation, it would be just all my x values would be between negative infinity to positive infinity. But if you want to write it in terms of an inequality or what is represented by that, well, what is between negative infinity and positive infinity? What kind of numbers are there? It is going to be all real numbers. So you could say all real numbers exist between negative infinity and positive infinity. But we can write a little shortcut. We can write the little shortcut and just put this little symbol, all real numbers. So like I said, you can, sometimes your teacher or your textbook or your software will tell you that it wants the answer written this way, but then other times this will be the acceptable way. Both of those mean the same thing. You just have to obey your software or obey your teacher and give them the answer in the format that they want. Okay, so let's also consider our range values. Our range values are the y values. Well, y values line up with the y-axis. How does the y-axis move? Does it move left to right or up and down? Well, it moves up and down. So that means we need to consider this graph. Where does it start and where does it go to? Where does it start and where does it go to? Well, it starts right here at the bottom right there. So, and we're going to assume that we know what that is. That should be probably 0 to 10, 8, 6, 4, 2. So that would be 9, right? So we're going to assume that that is at 9, negative 9. So that is where it starts. It starts at negative 9. And then again, these little arrows up here, they are indicating that it is continuing on forever and ever and ever, which means that it's going to go to positive infinity. At the top are the positive values for the y-axis. It is going to start at the -9, and it is going to go to positive infinity. You can never reach positive infinity, so you put what I call a soft close. The parentheses means soft close. You can never actually get there. It's not equal to infinity, but it is equal to the 9. I call this a hard box closure because it can actually be equal to the -9 at that point right there, the vertex. Okay, but if we want to write it in terms of the y's are going to be bigger than or greater than this -9. They're not going to be below it. They're going to be above it, above that -9, or greater than that -9. So I could also write this answer in terms of, I could say -9 interval notation, -9 to positive infinity, or I can say that my y values are greater than or equal to -9. So for our purposes, for some of you that are going to be looking at this right now, you probably want to go ahead and write your answer in this format for the ones that are looking for it this week. Okay, just click on the subscribe button. And I forgot to tell you, is it a function? Yes. All quadratics are functions. All quadratics are functions because of the vertical line test. I can draw a vertical line anywhere along this parabola, and it is always going to just hit it in one spot. Vertical line test says, will it hit it in more than one spot or just one spot? If it's just one spot, then yes, it's a function. It passes the vertical line test. Okay, I think we're finished now. So click that like button, click the subscribe button, and we'll see you back next time.